Are you grad student or undergrad?
Oh, great.
Okay. Because I saw you're taking classes, I was like, damn. Like, we're on taking 2 classes and I'm done.
I don't. So I don't work.
Oh,
So
I see. I see.
I got a few times.
No, I work out on weekends. That's why I'm always behind. I'm always procrastinating. Yeah. Also, the job market for you right now, it's so bad. Yeah. Here's the thing, right? So stuff will pop up. I would apply. And then they're like, okay, like if I'm lucky, I'll get like a first round interview. And then you straight up, they go like, bye. I'm like, dang it. For nothing, man. Why? Professor, I have a question.
Sure.
For the first homework, are you gonna upload the solution?
Yes.
Okay.
Yeah. So I usually do that the week before the midterm. So I'll upload just all the homework solutions that week. So
Oh, okay.
yeah.
Okay.
Mhm.
Because the only thing I'm kind of like don't know if I even did it. I didn't do it, to be honest.
Mhm.
Because I was very confused and I wanted to like see how to do it.
Mhm.
So I just wanted to. If you got some time after class, can you definitely
Yeah.
do it?
Yeah, definitely. We can definitely do that.
Okay.
Yep. There's another class in here after, but we can go back to my office. So we can
Okay,
chat.
sounds good. Yeah.
Mhm.
My other class, anyways, is kind of asynchronous in a
Mm.
sense.
Okay.
I have Dr. Habib.
Okay. Mhm.
So you know how he, like his class is basically, okay, if you can't show up, you can be online. If you can't be online, you can show up asynchronous.
Mhm.
And even the exams for the most part, just like take home exams. So
Okay.
I'm not too worried too much about this class as much as I'm like, I want to learn this class and understand it,
Mhm.
especially because FEA is going to be very, it's one of those things where it's like, it's applicable to industry.
Oh yeah. Mhm.
And I'm
Definitely.
like, I want to understand it very well. So that way, even if I don't do anything related to it, but they ask me questions, I know how to like think about it.
Yeah. No, for sure. Yeah. It's a great tool to have in your toolbox for sure. All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today? Good, good. Everyone looks happier today to be able to do ANSYS. I'm sure everyone's excited. All right, so I know ANSYS is not the emphasis for this class, and we're only doing a couple of these, but like I mentioned before, I do want to make sure that you guys leave this class with at least a little bit of experience with ANSYS. And my hope is that when we do our ANSYS activities here, hopefully you guys will see the connection to the theory that we're doing. Of course, in ANSYS, we're not going to be doing the calculations, right? We're not going to be forming the matrices ourselves. But the overall steps, I hope you kind of, appreciate is kind of the same. Okay. All right. So today is our first ANSYS activity. So this is kind of the first activity that I've been running for years now. It's kind of the very traditional kind of baby's first finite element analysis. And so it is a plate with a hole, right? So the situation we have is that we have this very thin walled plate here. On one side, it's going to be fixed to the wall. And on the other side, we are applying a tensile force. And we have a hole that's essentially drilled in the middle. And so what we want to do is we want to run a finite element analysis of this to first of all predict how much the plate is going to deform, and also how much the plate is going to or what the stress distribution is going to look like in the plate as well. Okay. All right, and so here are the dimensions of the plate, and so we'll be using this in our analysis, and we'll be using ANSYS for the first time today. So for those of you following at home, hopefully everyone here had a chance to download ANSYS and to your home computers. And obviously people who have had me before have seen this example before, so this is not new. And for those of you in the class here, you'll be able to use the ANSYS that's installed here on the lab computers. I hope. And so the thing with ANSYS is that we have to renew the licenses every year, and usually that's something I check in the fall. But last semester I was off on parental leave, so I'm hoping it's working today. I did see that it was installed, but if it's not, we'll have to improvise somehow. And so we'll just hope everything is good to go. Okay. All right. So, for this class, there's no, besides installing the software, there's no prerequisite. I've already had a couple of people kind of told me that they don't even know how to launch ANSYS, which is very typical. ANSYS is not a software that makes itself easy to operate. So we'll be going just first thing, just even launching the software from today, and then we'll go from there. There's an online version on the website, but it doesn't work for some reason. Is that through the ANSYS website or through the school website? I know that there was kind of a cloud. They were experimenting with kind of like a cloud version here on campus. Oh, the ANSYS student one. Oh, okay. Oh, that's interesting. I didn't know that they had one available online. So if that works for you, you can definitely do that, because it's definitely not a lightweight program. So for those of you who installed it, it's pretty heavy. So if you can avoid installing it, it's always helpful. But yeah, I personally haven't tried that before, so I can't really comment on that. All right, any questions I can answer before we get started for today? Okay. All right, so let's start. Just very first thing, let's launch the program. So the thing about ANSYS is that ANSYS is as a company is kind of trying to be the #1 player in the finite element space. In a lot of ways, they're very successful, right? And so, a lot of times when you talk about finite element analysis, for most people that aren't really in the field, they think of ANSYS as kind of the big name in the field. And the way it's kind of gotten to this point is that it's, I was telling someone before the class that ANSYS is kind of like an amoeba, where, there's been a lot of other smaller finite element companies that have popped up, and then ANSYS just uses its superior, money and resources and just kind of gobbles them up. And kind of just adds it to their own software suite. But the way ANSYS does this is that it doesn't really change much about those programs. It doesn't really try to fully integrate it with ANSYS. It just kind of takes those programs and just kind of duct tapes it onto ANSYS and just calls that little Frankenstein thing an ANSYS program. So the way to launch ANSYS is that there's kind of a manager software that kind of manages all the different parts of ANSYS, and that's called a workbench. And so to launch ANSYS, assuming that you have ANSYS installed in your computer, you're going to search for Workbench, and you're going to see that there should be a program called ANSYS Workbench 2025 Looks like the one that we're using here in class is R2, but if you've downloaded the student version from the website, they might be on 2026 R1 already. Because usually R2 is released in the second half of the year, R1 is in the first. Okay. But for our purposes, it doesn't really matter what version you're using. We're just going to use the basic features, which should be consistent across all versions of ANSYS. Okay, so let's go ahead and click on Workbench 2025 R2, and let's just pray that this works. Okay, let's pray that the licensing is there, and it's looking good. Usually if it gets to this point, then the licensing works. So I owe the IT guy a coffee because he did this for me this year. All right, we're good to go. All right, so when you first open up ANSYS, and if it's your very first time, they may ask you they're going to ask you here if they want to steal your data. Typically, I say no. I'm usually not a fan of volunteering my data to these big companies, but you can help improve their software if you want. It doesn't really matter. It doesn't really change the experience. Is it not going to let me say no? Hello? Excuse me? Not responding. Oh man, they really want my my data. Okay, all right, we're good. Okay, so when you first open up Workbench, you're kind of greeted with this kind of interface here. So there's kind of a lot going on. So let's just kind of go through. Let's kind of go through in terms of how you would actually start an analysis here, right? So where you first need to look here is kind of on the left-hand side for this toolbox, okay? So the thing about ANSYS, like I mentioned before, ANSYS is able to do lots of different types of analysis. So you can see some examples here. So you can do like a steady state thermal simulation. You can do a thermoelectric simulation. You can do transient simulation, transient structural, transient thermal. You can do fluid simulation, and there are, for some reason, 3 different softwares for computational fluid dynamics. You can do explicit dynamics, right? And so, this toolbox here kind of tells you all the different types of analysis you can run in ANSYS, right? Says, because the thing with finite elements is that, finite elements is not just structures. And I think people kind of associate finite elements with just kind of structural analysis. Really, if you have any kind of physical system that is governed by a differential equation, you can analyze it using ANSYS, okay? Now, for the most part, I would say finite elements has really made its name in certain structural analysis. And that's what we'll use, but, you just keep in mind you can use finite elements for lots of different types of analysis, okay? So the way to kind of start here is you first need to choose what type of analysis you want to run on your subject, okay? So for our purposes, let's look back at our problem, okay? So our problem that we want to simulate in this case is a plate with a hole, and we're applying a force here, right? So very similar to the types of problems that we've been doing in the class up until this point with the direct stiffness method, okay? So this is a static situation. So there's nothing really changing with time because all the boundary conditions are basically static, right? So they have kind of a fixed value. And so because of that, the type of analysis that we're going to use is static structural, okay? Now to start a static structural analysis, you can click static structural here, and you can drag it into the workspace here, okay? So that's one way you can do it. Or you can double click and it does kind of the same thing. Okay, so after you click and drag static structural, or after you double click, you'll be greeted with this menu here, okay? Now this menu here will kind of tell you, all the steps that you need to know, or all the steps you need to do in order to run a simulation, okay? So first we need to specify the engineering data. So we'll go over that in a second. Next, you need to specify the geometry. And then next you do the mesh and the boundary conditions, and then you get the solution. Okay? Question, yes.
So what did you first click on to get this window?
This whole thing. So to get this, you have to launch a program called Workbench. And so if you, the way Windows does it's kind of weird now. So I usually just click on the start menu, I search, and you search for Workbench, and you click on Workbench 2025. or
It's
23?
just that I have it open, it's just I can't, for whatever reason, it won't let me get that little, like, the static structure engineering data and all that.
Oh, so you opened up Workbench, but there's nothing in this box here.
Oh, no, there is, just that, I don't know what.
Let me see real quick. Oh, static structural,
Oh, okay.
and you double click that. Yep. Mhm.
I think-
Okay. All right. So actually, so the first thing we're going to do, so we're going to do kind of a weird step in this activity. So this is specific to just this one, because this geometry that we have here is essentially a two-dimensional geometry. So we're not really going to consider any analysis in the depth of the page. So we need to tell ANSYS beforehand that we're running a 2D analysis. And so to do that, you can right-click anywhere. You can right-click on any of these boxes in your static structural here. Okay. And then you're going to click on properties. Okay. Okay. Actually, I'm sorry. So you're going to right click on geometry and click on properties. Okay. So you right click on geometry, click on properties, and then you're going to go to one specific section on this here, line 19. Okay. You can see the default type of analysis that ANSYS will run is a 3D analysis, which is a very reasonable assumption because for the most part, you're using FEA to do three-dimensional analysis. Okay. It's just that for this particular activity, just to keep things simple, we're doing a 2D analysis. We're going to switch this from 3D to 2D. Okay. So make sure you do that. And so, otherwise, some things later on, the options will be a little bit weird. So you want to make sure that you switch to 2D analysis. Okay. Okay. Good. All right. So next thing we're going to check. Technically, this is done for us already. But we are going to check to make sure that we have the appropriate material properties. Okay. Now, one thing to kind of to highlight before that is if you notice that next to this tab here for engineering data, we have a green check mark. Okay. So usually when you see a green check mark within ANSYS, that usually tells you that ANSYS has all the information it needs. There's nothing for you to kind of input yourself. Okay. And so technically our engineering data is already set because ANSYS kind of automatically loads in some default materials, but let's check it just to make sure. Okay. So let's double click engineering data. Okay. And so by doing so, it'll open up this menu here, which has all the different materials that you have loaded in your system. Okay. Now there's only a single material that we have loaded, which is structural steel. Okay. So structural steel is kind of the default material that is within ANSYS. Okay. You can add new materials if you want. So you can add custom materials. You can add some pre-built materials within ANSYS. We'll do that in activity 2. But for now, we're just going to look and see what's available for structural steel. Okay. So if you left click on structural steel, it should already be selected because it's the only material. And you go to the bottom of the screen, you should see the material properties here. Okay. Okay. So the properties of structural steel are outlined here. So, for the most part, we're not going to use most of these, but there are some that we do need to check. Okay. So the one thing we need to check mostly is the Young's modulus. Okay. So if to see the Young's modulus, right, it may not be apparent at first, but Young's modulus belongs to the type of material or type of property called isotropic elasticity. Okay. So go ahead and click on the plus arrow here to expand isotropic elasticity. And let's check the Young's modulus. Okay. So the Young's modulus for structural steel is 2 × 10⁻11 Pascal. Okay. Okay, so let's go back to our problem document and let's check and make sure that that Young's modulus is consistent with what we need for this activity. Okay, so for this activity, our Young's modulus is 2 × 10⁵ megapascal. Okay, right, and so we go back to our workbench here. Right. And so, if you know the conversion between Pascal and megapascal, you'll see that these are equivalent. Okay. But if you're not sure, you can always change the units here. So you can change the units here to MPa, which is megapascal. And you can see that our Young's modulus is indeed 2 × 10⁵ megapascal. Okay. So our Young's modulus is correct. Right. The other thing we'll check here is the Poisson's ratio. But thankfully, Poisson's ratio is unitless. And so Poisson's ratio for this material is 0.3, which is exactly what we need for this analysis as well. Okay. So, when you're using ANSYS, there's a lot of different settings that you have to set. But one thing that often gets overlooked are the material properties. So you always want to make sure that whenever you're running a new analysis in ANSYS, you always check the material properties. Okay. So if you think back to all the problems that we've done in the class so far, the material properties is always something I give to you, right? So I give you guys the Young's modulus, I give you guys the length and the areas. And so you want to make sure that you check it to make sure that it's correct. Okay. Otherwise, the results that you get from your analysis are not going to be correct at all. Okay. Any questions on this? Okay. All right, so that's so now that we've confirmed the material properties, let's go ahead and close this. And so to close out the engineering data, there's basically a tab up here that you can close. Okay, so go ahead and click on this X right here. So that's going to bring you back to our workbench area. Okay. Okay, so next step is we're going to construct the geometry. Okay. Because right now, we haven't assigned any geometry to our simulation, but we need one in order to run an analysis. Okay. So to make a geometry, you're going to right-click on geometry here, okay? And you're going to open up one of the CAD softwares that's packaged within ANSYS itself, okay? So ANSYS actually does come with a couple CAD softwares. And so, like I said, ANSYS is trying to be kind of the one-stop shop for all of your CAD and analysis needs. I wouldn't say that these CAD softwares are nearly as robust or easy to use as SolidWorks. It might be better than CATIA. Apparently, CATIA is not fun to use, but I've never used CATIA, so I'm not sure. Is it okay? I see. All right. Well,
that's all I gotta say.
Okay. So we got some CATIA fans and some CATIA haters here, so I'll be impartial. But but I will say that I'm not a fan of ANSYS's CAD softwares. I do prefer SolidWorks. But for this simple problem here, the ANSYS CAD softwares would do just fine. Okay. So you can see that there's two here. So Discovery is kind of the new CAD software that comes packaged with ANSYS. We'll not use that one. So we're going to use the OG one, which is the design model. Okay, so go ahead and click on New Design Model or Geometry. Okay. And that's going to open up a new program that we're going to use to make the geometry. Okay. Now, typically, I would say for a normal ANSYS workflow that you're going to use, like let's say at your job, typically you're not creating the CAD geometry within ANSYS, although there are a lot of benefits to doing so. Typically, you're going to create the CAD software in another, or you're going to create your CAD model in another software and then import that into ANSYS. And so we'll learn how to do that in activity 2. Okay. But for this activity, just because it's so simple, we're just going to draw it out here in ANSYS. Okay. All right. So once you open up Design Modeler, you should be greeted with this figure right here. Okay. All right. So first thing we're going to do is we're going to make sure that we are looking straight down the Z-axis. Okay. So in the bottom right-hand corner of the screen, you should see an XYZ axis here. Okay. So we want to change our perspective so that we're looking right down the Z direction. Okay. It's a little bit hard to tell because our model here is completely blank right now. But this is an important step just to make sure that we're sketching on a planar surface. Okay. So go ahead and left click on the positive Z-axis here. So left click on this blue arrow, and that'll change your perspective. So now we're looking straight down on the XY plane. Okay. Okay. All right. So first thing we're going to do is we're going to make a sketch. Okay. So go ahead and left click on sketching on the bottom left-hand side of the screen right here. Okay. So sketching is this button right here. Right, so let's click that. Right. And then by default, we are going to be sketching on the plane that we're looking at, which is the XY plane. Okay. Okay. So we want to be able to sketch our rectangular geometry here, right? So first thing we're going to do, we're basically going to sketch out the rectangle. Okay. But we're going to make sure that we're in the right unit system because, if you look at the dimensions of this plate has a length of 300 millimeters or 30 centimeters. And a width of 200 millimeters or 20 centimeters. Okay. You want to be careful here because if you don't put the right unit system, you could be making the geometry, and it's not unsalvageable. It's just more annoying if you don't change the units beforehand. Okay. Because if you look at kind of the dimensions that we're in right now, right, we can see here that we're in units of meters, and so this distance from here to here is 30 meters. And that's way bigger than what we need for our application here, which is 300 millimeters. Okay. All right. So first thing I'm going to do is I'm going to go up to the top of the screen, and we're going to change our unit system. So we're going to left click on units up here. Okay. So click on units. You can see here that we have some selections here. So we have the SI units, so meters, centimeters, millimeters, micrometers, and we have even have some US customary units here, foot and inches. Okay. So for our purposes, either centimeter or millimeter is fine. I'm going to pick centimeter. Okay. And you can see by doing so, we've kind of essentially zoomed in quite a bit, where now we're looking at an order of 40 centimeters here, which is much nicer. Okay. Okay. All right. So now that we've kind of done all that, we are ready to start drawing. So first thing we're going to do is we're going to draw just the outline of our rectangle. So from the sketching menu, you're going to click here. You're going to click on rectangle. Okay. Right. And then you're just going to sketch a rectangle. So the exact size of the rectangle doesn't matter at this point. We are going to dimension it, but we just need a rectangle to start with. So I'm going to left click here and then click and drag. Right. And then I'm going to draw my rectangle that way. Okay. So now we have a rectangle that we can start with. All right, so let me pause here for a second. Everyone keeping up? Everyone able to draw the rectangle in Design Modeler? Okay, good. Okay, so next step we have here is we're going to dimension this rectangle. So we basically need to we basically need to specify its length and width so that it matches up with the geometry that we have here. Okay. Okay. So to assign dimensions, it's a little bit different than ANSYS, or a little bit different than SOLIDWORKS, excuse me. And so to create a dimension, we're going to click on this button here called Dimensions here on the left-hand side of the screen. Okay. And you can see here that there are several different options here for dimensioning. So you can apply a general dimension, horizontal dimension, vertical dimension, length dimension, radius, diameter, all of this good stuff. Okay. So we're going to start with the general dimensioning tool. Okay, so that basically lets you click on a certain feature in your geometry and specify its length. Okay, so first let's specify the length of this rectangle here. So with the general dimension tool highlighted, we're going to click on a horizontal edge of this rectangle. So I'm going to click on this one here. Okay. And doing so means that we're going to assign a dimension. So we're going to click and drag this out just like that. Click again. Okay. And now we have this dimension. It's a little bit hard to see, but that that there says H1 essentially. Okay. Oh, and by the way, if you want to zoom in, hopefully you're working with a mouse with a wheel, so you can scroll up and down the mouse wheel to zoom in. Okay. If you want to rotate, you can left click on the mouse and rotate. Oops. Well, we're going to do that anyway. That's fine. But it's not working now because I have the dimension tool. If you want to pan, you can click on the mouse wheel. I think I have to click off of the dimension tool. Whoops, where'd my thing go? I accidentally zoomed in. There we go. Okay. Okay. I apologize. It's been literally a year since I've used ANSYS. So if you want to pan, the way to pan is you hold Control on the keyboard, and then you click down on the middle button. And so doing so will let you kind of pan left and right. So that's usually pretty helpful. Okay. Okay. All right. All right. So we've created our dimensions, right? So normally in SolidWorks, I think people are accustomed to, once you kind of make a dimension, you can kind of specify the value right in the graphical user interface. But for Design Modeler, it's actually a little bit different. And so, after you create a dimension, right, keep note of the name of the dimension that you created. Okay. And then where you're actually going to specify its value is actually down here in the bottom left-hand side of the screen. Okay. So for instance, we have this H1 dimension. So that this H1 dimension is specifying the horizontal length of this rectangle. And so let's set this to be equal to what we need for this problem, which is 30 centimeters. Okay. So 30 centimeters, 300 millimeters are the same. Okay. So let's go here. Let's enter 30. Let's make sure my nums lock is on. Okay. And you hit enter, and then that will specify the length of that edge. Okay. We're going to do the same thing for V2. So V2, that is our vertical dimension on our rectangle here. Okay. I know I clicked this one on accident. So if you haven't specified a general dimension on that, go ahead and do that. Okay. That vertical length of that rectangle is going to be 200 millimeters, which is 20 centimeters. Okay, so this is 20. Okay. So now we have our rectangle there. Okay. Okay. Good. Any questions on this so far? Okay, good. All right, so our rectangle is the right size now, but it's not centered, right? So ideally, we would want to center this rectangle on the origin, because eventually, we're going to place a hole there. And so let's move this rectangle. Let's translate it so that it's centered on the origin. Okay. Now to do that, we're going to make use of a different dimensioning tool, right? So first, let's center the rectangle vertically. Okay. So under dimensions, you're going to click on vertical dimensions here. Okay. And this vertical dimensioning tool will let you specify the vertical distance between two features in your geometry. Okay. So in our case, we're going to specify the vertical distance between one of the edges of our rectangle and the x-axis here. Okay. So with the vertical dimensioning tool highlighted, you're going to left click on one of the horizontal edges of your rectangle. Okay. And then while that one is highlighted here, so you can see here it's highlighted yellow, I'm then going to left click on the x-axis of our system here. Okay. And so by doing so, we create a new dimension here called V3. Okay. And then we can specify its value here. And so in order to center it, we're going to set V3 to be half of the vertical height of our plate, which is 10. Okay. Okay, so we set that as 10. Now our plate here is centered vertically. We're going to do the exact same thing with the horizontal length here. So we're going to click on horizontal here. Okay. Click on one of the vertical edges here. Click on the y-axis. Okay. And we're going to specify that length. We're going to set that to half of the horizontal length of the rectangle, which is 15 centimeters. Okay. Okay, so now we can see that our rectangle here is perfectly centered on our origin. Okay. And one thing you should notice here is that, once you've kind of fully specified, the geometry, you can see here that all of these sketch lines have turned this kind of like, azure blue. And so once it kind of turns this kind of like this deep azure blue, that means it's fully specified. And so that geometry is not, it doesn't have any more degrees of freedom, which is typically good, right? So if you remember from your CAD class, typically you want to fully constrain or fully dimension your geometry. And so this is kind of a good check just to kind of make sure that you do that. Okay. Okay. Any questions on this so far? Yes.
Is there any way how to rename the dimensions? Like V4?
That's a good question, actually. I don't know if there's an easy way to do that. So usually, the way ANSYS does it is that it uses a letter. So the first letter tells you the type of dimension that it is, and then the numbers are actually unique. And so H1, that was the first dimension that we specified. V2 was second, V3 was third, and H4 was the fourth. Mm-hmm. But I don't know if there's a convenient way to rename it. Let's see. Yeah. Usually you can click on something in ANSYS and put F2 to rename it. But it looks like, oops, well, I don't want to do that. No, my data. Okay. But it looks like that's not available for this. Any other questions on this? Okay, good. All right, so next thing we're going to do is we're going to draw our hole. Okay. Okay, so let's go back to the draw tab. So let's go ahead and left click on draw here. Okay. And then to draw our hole is just a circular hole. So let's go ahead and left click on circle. Okay. Right, and so since we've already centered our rectangle on the origin, we can go ahead and move our mouse to the origin. You should see that our mouse kind of snaps there kind of automatically. Right, so let's go ahead and left click once just to tell ANSYS that we want to make a circle there. And then we'll drag our mouse out to kind of complete the circle. So it doesn't matter what size circle that you pick for now, we are going to dimension it. So just left click anywhere and then to create our circle that's in the middle, just like that. Okay. Okay. And so last thing that we're going to do is that we are going to dimension the circle to make sure it's the right diameter. Okay. So you can see here that from our page here that our diameter for the circle is 50 millimeters, and so that's 5 centimeters. All right, so once again, we'll go back to the dimension tool here. Click on general dimension. Click left click on the circle. Okay. Drag that out. We can see we have this new dimension D5. And so let's specify this to the right value, which is 5 centimeters. Okay. All right, good. All right, and so with that, our sketch is complete. And so last thing we need to do before we exit out of here is we do need to turn it into a surface, because right now this is just a sketch. And so we need to make sure that it's suitable for finite element analysis. Okay. But any questions on just making the circle and the hole? By the way, for Zoom people, I don't know if the speakers here are working, and so if there's any point in the tutorial that you want me to pause and you have a question, just type something in the chat really quick. I know it takes a while to kind of type in the chat, so maybe just type really quickly, just say stop, and then I will stop. I'll let you type, and then I can answer your question that way. Okay. All right. So now that we're done with our sketch, we do need to turn this into a surface. Okay, good. All right, so let's go ahead and do that. So let's go ahead and return back to the modeling tab. Okay, so let's go ahead and left click on this modeling tab right here. Okay. All right, so that will bring us back here, right? If you left click on the XY plane here, you can see here that now there is kind of an expandable thing you can click. You'll see that we have one sketch, sketch 1, and that is the sketch that we just made here, okay? Okay, so to turn this into a surface, we are going to go up to this concept menu up here. Okay. So concept is on kind of the ribbon menu at the top. So left click on that. All right. And then we're going to click on this option here called surfaces from sketches. Okay. Which in this case, we're just going to make a singular surface from a singular sketch. Okay. All right. So we'll go ahead and left click on surfaces from sketches. All right. So that's going to create this new object here, surface from sketch. Okay. All right, so the way this works is that we need to basically load in a sketch or assign it to here that we want to turn into a surface, okay? And so to do that, right, you're going to left click on sketch up here, right? So make sure this sketch is selected. And then you're going to come down to the bottom left-hand side of the screen, and then you go down to this option called base objects, and then you're going to click apply, okay? So if you do that correctly, you should see that this option here for base object should say one sketch, okay? And that one sketch should just be this one sketch that we made, which is sketch 1, okay? Okay. All right, so the next thing we need to do is we do need to specify the thickness of this surface, okay? So even though technically we're going to be doing a 2D simulation, we do need to specify the thickness of the plate just because our equations are in 3D, okay? So our thickness here is 5 millimeters. And so 5 millimeters is half of a centimeter. Okay. So under the thickness option here in the bottom left, right? So it's asking for us to specify thickness. Let's go ahead and specify 0.5 centimeters. Okay. Right. So after we specify the thickness, we just double check to make sure that we have the sketch here. We're going to click on generate. Okay, so generate is this kind of button right here with the lightning bolt. Okay. So go ahead and click that. And if everything is good, you should be able to see our surface kind of materialize here. Okay. So ANSYS is smart enough to see that, when you have an enclosed sketch like this, you want to turn into a surface. But if you have other enclosed surfaces or enclosed sketches within your enclosed sketch, ANSYS knows to kind of make that into a hole. And so to not kind of fill it in with material. Okay. All right, and so with that, our geometry is complete. Any questions on this? Everyone able to kind of get the whole
question?
Yes.
So we gave it a little thickness. So what's the difference between that and the extrusion?
Yeah, that's a good question. So remember, remember when we started this, we said that this analysis is 2D. Mm-hmm. So actually, let me do this. So actually, if you rotate it, right, you'll see that our plate here doesn't actually have any thickness, right? So this is kind of a true two-dimensional analysis. So this thickness here, I think a lot of times when people think of thickness, they think of like an extrusion thickness, and that's totally fine to think of that. But since we're doing a two-dimensional finite element analysis, this thickness is kind of more like a material property instead of an actual physical kind of thickness that you can see, right? So actually, if you think about kind of the finite element problems we've done so far, right? If you think of like your truss bars, we assign like the cross-sectional area as like a parameter of that truss, even though we're not actually looking at that. We're doing just a one-dimensional analysis, but that area was just a parameter. This kind of works the same way. Yeah. Good question, though. Very, very good question.
You showed me added the thickness again.
Sure. So when you added the thickness, it was through this surfaces from sketches kind of tool here. So go ahead and click on surfaces from sketches. Basically, we're going to create a surface from that sketch that we just made. And so the thickness is added as a setting from that surface from sketches option. So that's kind of in the bottom left-hand corner of the screen right here.
Got it.
Yeah. Question, yes.
So, because for whatever reason, my the software just froze, so I had to literally close it and open it again.
Yeah.
So I didn't save anything at all. But right now I'm running into a problem where the engineering data is not giving me anything.
Oh, let me take a look real quick. Go ahead and close out of this. I'll double click on it again. I'm guessing it's there because sometimes what can happen is that these menus kind of get mixed up. And so you may have to reset the interface here. So maybe view, go to view, reset workspace. And then go ahead and close this again. Double click engineering data again.
And then
no, let's see. Go ahead and click on engineering data sources again. Let me go back. I think you're okay just because there's a green check mark there, but yeah, we'll double check once we get to the
Okay.
Yeah. Okay. All right. Any other questions before we move on to ANSYS mechanical? Okay. All right. So now that our geometry is set, we can actually just close this window here, which is a little bit unnerving because technically we haven't saved anything yet. But remember, ANSYS is a collection of different softwares that kind of all work together. And it's actually auto-saving your geometry kind of all the way through. So let's go ahead and click on the X here. Let's close out of Design Modeler, okay? And you return back to Workbench, right? And so you should see here that after doing so, now our geometry has this green check mark because now it has a geometry that it can work for the analysis, okay? Okay, so the next step is to open up a different program in ANSYS called ANSYS Mechanical. So ANSYS Mechanical is actually where we're going to do the bulk of the analysis. So to open up ANSYS Mechanical, go ahead and double click on Model here. Okay. And that's going to launch the ANSYS Mechanical software. And so while that's launching, let me see what we're doing. It's interesting because this is actually the paid, it's just a sample. But this is the paid package within ANSYS to have this material properties. So
I think it's really so we need to go back and tell ANSYS because it's 3D, not 3D.
Yes, but the material properties are usually in the well, you have structural steel. So I mean, this is structural steel. So worst case, when we go into ANSYS Mechanical, just make sure we set it. Okay, yeah, you should be okay. Okay. Oh, this is new. Okay, so you can choose your theming for ANSYS Mechanical. So you can go dark, light, or classic. My friends have told me endlessly that I'm a psycho for preferring light mode. They're scared that I'm gonna kill them in their sleep or something like that. So I guess if you're not a psycho, you can pick dark mode, but I do like the classical look. So I'm gonna click on classic. Yes.
Can you show me one more time? You get to that?
Oh yeah. So to open up ANSYS Mechanical, you're going to double click on model here. So make sure that your geometry is set. So make sure you have the green check mark on geometry and just double click on model here, and that'll open up ANSYS Mechanical. Yeah. Okay, so the first time you open ANSYS Mechanical, they might try to get you to like and subscribe their YouTube channel. So I mean, you can do that if you want. But to bring back your geometry, you can left click on model A4 here. And you should see that your geometry should hopefully be successfully loaded here. Okay, so I know this is kind of the phase where I think people kind of get to different, they kind of get stuck on different parts. So usually what I'll do here is I'll kind of, try to get to the end, and then I'll go around and kind of help people individually for the last, 20, 25 minutes of class. Okay. All right, so we have our geometry here. So first thing we're going to do is we're going to confirm our material properties. Okay. So to confirm our material properties, you're going to left click on geometry here. And you can see that we just have one body here, which is the surface body. So go ahead and left click on that. Okay. And then in the bottom left, you should see a setting here for the material assignment, which in this case is structural steel, which is good. Okay. Okay. All right. So the next step in any finite element analysis is we need to mesh the geometry. Okay. Now this step I think is a step that we haven't really appreciated so far in this class, just because for the most part I've been giving you the geometry and the discretization and the elements. But in reality, when you take a general geometry like this, an important step for FEA is you need to break it up into elements in order to do the analysis. Okay. And so that step is called meshing. And so you can see here that there is a yellow kind of lightning bolt next to mesh. And so that's ANSYS' way of telling you that you need to specify a mesh before you can continue with the analysis. Okay. Okay, so to generate a mesh, it's very simple. So you can right click on mesh here and click generate. Okay. Okay. Right, and then doing so will get you this mesh right here, right? So you can see that we've taken our geometry and we've basically broken it up into these much simpler shapes here, right? So we have some squares, we have some triangles, we have this thing. I don't know what shape that is, but and this one looks kind of weird too. Okay, so this is a mesh right here, right? So remember the idea of a mesh is to take your geometry, break it up into simpler shapes. Okay. Now this mesh right here, I wouldn't characterize it as good, okay, because it's a very coarse mesh, and so our elements here are quite large. So typically speaking, you want, in order to get accurate results, you want to make sure that your mesh has elements that are sufficiently small. Because generally what we expect is that the smaller your elements are, the more accurate your simulation is going to be. Okay, so let's go ahead and change that. Actually, first thing, let's change our units just like we did before. So let's go up to units right here. Let's change our units to centimeters, just like before. Okay. All right, and so if you left click on mesh right here, you can see in the bottom left that there is a setting for you to control the size of the mesh, right? So right now we're going with the default size, which is 3.0116 centimeters, okay? So if you're wondering how ANSYS gets this size, they kind of just look at the overall size of your CAD model, and they just choose a percentage of that, okay? So let's make this smaller. So let's make our element size 1 centimeter. Okay. And then let's regenerate our mesh. Okay. So you can see after we've changed the size, our mesh here now becomes obsolete. Okay. So let's right click this and let's generate our mesh again. Okay. All right. You can see now our mesh looks much nicer. So our elements are much more uniform. They're much more, less distorted. We have less weird elements here, right? And it's a much, much nicer looking mesh. Okay. So, in the second half of class, once we get to kind of more general FEA, we'll talk about meshing a lot more and what effect that has on your solution. But, for the time being, you can just imagine that smaller elements are good. Okay. Now, of course, you can continue to make this smaller. Okay. So don't do this. 1 centimeter is good, but I just want to show you. Okay. So we can make this even smaller. So we can make this, maybe 0.5. I think that should still be okay. Okay. We can regenerate our mesh, right? So we get even smaller elements. We can make this even smaller, 0.25. You can see what that looks like. Okay. So, you can keep going. And so you might be asking, if smaller elements are good, what's stopping this from making this like, 0.001? Well, generally speaking, the more elements you have, the more accurate your solution, but that also means your cost is going to go up as well. Okay. And by cost, I mean, how long your simulation is going to take and how much computational resources it's going to take as well. So that's memory, RAM, processing power, things like that. Okay. So there's a balance. And so, you want to make your mesh fine enough, but you don't want to make it so fine that you blow up your computer. Okay. So for our purposes, 1 centimeter is perfectly fine. That is going to get us great results. But I think, part of the activity that I'm going to have you do afterwards is to play around with the mesh. So, that's one way to do it. Okay. All right. Any questions on the meshing? Yes.
Right. Double click on the model thing to open the what's going
ANSYS mechanical.
Yeah, that's still loading.
Okay. Let me kind of get through the end, and then I think I'll kind of visit people kind of individually afterwards. Okay. All right. Any other kind of quick questions I can answer? Yeah, I know this is the part where people kind of fall by the wayside just because things are ANSYS is kind of a fickle beast sometimes. Okay. All right. So next thing we need to do is we need to apply our boundary conditions. So hopefully this step is pretty familiar to you guys because we've been doing it for weeks now. Okay. So we have 2 primary boundary conditions that we need to apply. So we have a fixed support that is going to be applied on the left-hand side. Right. And on the right-hand side, we have a tensile force. Or in this case, I think it's a tensile pressure. And so let's go ahead and apply both of these as boundary conditions on our model. Okay. Okay, so let's go back to ANSYS mechanical. Okay. Let me go ahead and clear this. Okay. All right, so first thing we're going to apply here is a fixed support. So let's right click on static structural A5. We're going to go to insert. Okay. Right, and so this basically shows you all the different types of boundary conditions that you can apply. So you can see that there's a lot of them. Okay. But the one that we're going to apply here is a fixed support, right? So let's go ahead and left click on fixed support. Okay. So you can see that'll create a new fixed support setting that you can kind of play with here. Okay. And so to use a fixed support, you're going to left click on the part of the model that you want to apply the fixed support to. And so in our case, we want to apply a fixed support to the left edge. So let's go ahead and click that. Make sure the edge that you want to select here is highlighted in green. And then we're going to left click on the bottom left here to apply. Okay. And so if you did things correctly, you should see that ANSYS should tell you that you're applying a fixed support on the left-hand edge of this plate. Okay. Okay. So let's do the same thing. Let's apply the pressure boundary condition on the right. So same thing that we did for the fixed support. Let's right click on static structural A5. Let's click on insert. Okay. And then let's click on a pressure boundary condition. Okay. So the reason I'm choosing pressure is if you look at the units for our loading, so you can see our units for loading here is 1 × 10⁴ megapascal. Okay. And so in order to keep things consistent, we want to make sure that we apply our loadings in the same unit system. And so let's go ahead and apply that as a pressure. Okay. So let's right click on static structural A5. Go ahead and click on pressure here. Okay. Same thing we did for the fixed support. We need to specify the part of the geometry where we want to apply the boundary condition. Okay. And so in this case, we want to apply the boundary condition on the right-hand side of the plate. So let's go ahead and left click sorry, left click on the right-hand side of the plate, okay? Make sure that just that edge is selected. We're going to go ahead and hit apply, okay? And then we're going to specify the magnitude of the loading, okay? Actually, I apologize. So we're going to change the dimensions, or we're going to change the type of the direction of the loading first, right? So first thing we're going to do, we're going to change this setting. So first thing we're going to say is that instead of being applied to, sorry, we're going to change the setting for defined by, okay? So we're going to left click on defined by, and we're going to change it to vector. I'm sorry, components. Sorry, it's been a year since I've used ANSYS. Okay. Okay. So you click on components. That allows us to specify the X component and the Y component of our loading individually. Okay. And we only want the loading to go in the X direction. Right. Okay. So let's go back to our document here. We want to specify the loading as 1 × 10⁴ megapascal. Okay. And so you can see here that the units for the loading right now are in dyne per centimeter square, which is the centimeter units. And so if you want to go to megapascal, you're going to left click on units up here, and then click on the third option, which is millimeters, kilograms, newtons, seconds, millivolts, milliamps. Okay. Okay, and so doing so changes our kind of force units here to megapascal. Okay. So let's go ahead and change this. So we're going to specify 1 × 10⁴. And so the way to do that is you can just simply type 1E4. Okay, so that's kind of the shortcut for 1 × 10⁴. Okay. Go ahead and hit enter. Okay. And you can see now we're applying a tensile force on that right-hand side in the magnitude of 1 × 10⁴ megapascal. Okay. All right, and so those are our 2 boundary conditions. Any questions on this? Okay. Okay. All right, and so that's it. And so we're now ready to run. But let's make sure that we can, we can view the results that we want. So to specify result fields, you're going to right-click on Solution A6. Okay. You're going to click on Insert, and you're going to specify the results that you want to see. Okay. So you can see here there's lots of different results that you can see. So you can view deformation, you can view strain, you can view stress, you can view strain energy. Okay. Linearized stress. So for our purposes, we're going to keep it simple. So we're going to look at the total deformation. So that'll show you just how much the plate is deforming. Let's go ahead and click that. And let's go ahead and right-click Solution A6 and then click on Stress. And so we want to view just the equivalent von Mises stress. Okay. Okay. So those are the only 2 result fields that we want. Okay. All right, and so that should be it. So then let's go ahead and run it. And so to run the simulation, there's kind of a big button here that says solve, or I guess you can hit F5 on the keyboard. Okay, so go ahead and click solve. Okay. If all goes well, assuming your mesh is not too refined, you should get your results in about maybe 10 seconds or so. 20 seconds or so. 30 seconds or so. Come on, ANSYS. Shouldn't take this long. There we go. Okay, good. Okay, and so first thing you can see here is we can view the total deformation, right? And so the way to view this is basically just a color contour plot, right? And so everything that's red here has a deformation of 16.847 millimeters. Okay, so that's how much we're deforming. And then we have a minimum deformation of 0, which is where we have the fixed support, which makes sense. Okay. All right. Next thing you can see here is the stress field. So you can see just how much or where the stresses are concentrating. This is usually why you run FEA analysis, is to view the stresses. And so this here is very valuable information. So you can see the stress is concentrating around the holes, specifically the top and bottom of the holes. Okay. And so that information can kind of help you with the structural design. All right, and so that's about it. And so, I do want to spend the last 20 minutes because I know some people are having some issues. So if you're having issues with your ANSYS, raise your hand. I'll come around to see you guys. If you're able to kind of get to this point, you can go ahead and work on the rest of the activity. So if you scroll down to the bottom of the PDF, you can see there are additional topics for you to do. Okay, so I want you to do things like, specify where the max deformation takes place, specify where the max stress takes place, change the loading, change the size of the hole, change the mesh size, and some other stuff. Okay. All right. So if you're able to get to this point, go ahead and start working on that. If you have questions or you have issues, raise your hand, and I'll kind of make my rounds. If you have questions on Zoom, just drop something in the chat, and I'll come back around for that. Okay. But technically, this is the end of class, and so if you don't want to be here anymore, you're free to go. So I'll kind of say this now. So thank you guys for coming today. I hope you guys have a good rest of your week. Hope you guys have a good weekend, and I will see you guys next Tuesday. Okay. Okay. All right. So next thing we want to do is we want to center this plate, right? So you've centered it. Okay.
Good question. Do they treat copy?
Okay. So right now, so this H5 right here, this is the total length of this pipe right here. So we actually want this to be 300 meters. Okay.
Not anymore.
That's what it is in the document. And then the height here is 200.
Then we can copy those. I never understand.
And then this this dimension here, we want this plate essentially to be centered on the so we want this L8 here to be 150. So you can see now that we're horizontally aligned. Okay. And now we're gonna center it vertically. So now I'm gonna click on this. Right, so now this is going to be
rotation.
Yep. So now our plate is centered. So now you can go ahead and draw your hole, and then dimension it, and then do the surface sketch. I'm gonna make my rounds, but yeah, go ahead and do that. I'll come back to you. Check. You still have.
Yeah, I just turn off the easy.
Oh, okay.
I'm gonna try to.
Yeah, you should.
But I did see.
Oh yeah, but they don't like to do that.
Let me just.
Yeah. So
make
for
sure
this
I'm
one,
using the correct
don't worry about the refinement. I know in the document here I talk about refinement. Don't worry about that for now. Just go ahead and delete it. Yeah, just go ahead and move on to the boundary conditions and the solution, and then you can do the refinement. Looks good. Very good. Good. No problem. Have a good weekend. How are we doing, Zoom people? Any questions from Zoom? Sorry.
Yes.
All right, I'm gonna make another round in the classroom, but yeah, if you have questions on Zoom, just leave in the chat. Okay.
And the reason why you can also look at the solution.
Perfect. Okay, so now that you're done sketching, you can go back to model here.
That it is.
Okay, so now we need to turn this sketch into a surface. So then click on concept. Click on surfaces from sketches. Okay. So now we need to assign the sketch to that object. Left click on this plus arrow here. As you see the sketch, go ahead and click on sketch. Put that apply here. Thank you. Yeah, no problem. Have a good weekend. And then click on thickness. And for thickness, we want that to be 5.
Then you know that this will be equal to 0.
Yeah.
Okay. Good. So now go ahead and generate.
If it was just like an error.
There you go. There's your surface.
It'd be.
Yeah. So now your surface is
something
ready.
like
So go ahead and
Yes.
let's exit out of here.
Do I need to save it or no?
No. So as long as you don't close Workbench, everything kind of saves automatically.
Okay.
But we can go ahead and close this design model.
Okay.
Yeah. Now we can go ahead and double click on model. And now you can do the meshing and the configuration. So it'll take a little bit of time to start.
Okay.
Yeah.
Yeah.
Oh yeah. So if you've used ANSYS if you use student ANSYS in previous years, that license only lasts for a year, and so you do have to re-download the new version, or you have to uninstall the old version and then download the new version and use that one. Yeah, that's kind of the unfortunate thing. So for people who've had me in the past use ANSYS, you do have to re-download the new one. Yeah. I see. I can't find the pretty box icon before clicking image to file. Ah. They might have moved the screenshot option, but for our purposes, the snipping tool is probably okay. But let me see. Display. Sorry. There's also a search bar.
No,
You can
there's
just search it.
wait. Is it this way? Oh, then I guess yeah. But it's due March 1st.
So the core functionality of ANSYS doesn't change year to year, but they changed the location of the buttons, which is very annoying. Yeah, I would say for now, to just to take your screenshots, you can just you can just take the snippet tool. So just if you're on Windows, do Windows key Shift and then S, and so that lets you kind of take a screenshot that way. That's fine for our purposes. Don't worry about the screenshot. Yeah. Oh, I always forget to do this after activity 1. But for those of you that are still here in the class, if you want to save this, right? So for this activity, probably is not the worst thing to do, just because I know it took us about an hour to do this, but if you're just kind of breezing through these settings, that's pretty fast. But if you want to save your work, right, you need to save it from Workbench. So click on Save. Okay. Now, if you're on your personal laptop and you're using it there, you can just click and save it, and then you can just save it as a project kind of folder, right? But the way ANSYS works is that it doesn't save a single project file like I think you're accustomed to from SolidWorks, and so it actually saves a whole folder. And so if you actually want to, let's say you're working on the lab computer here, and you want to take your project home to work on your personal computer, you do need to archive it. And so click on Archive. First of all, you need to save. Let me save first. So let me save this under my documents here. Let me click on, let me say, EGME 541, Spring 26, ANSYS, Act 1. Okay. Okay. All right, and then it's going to ask you to archive it. So the archive file has this extension WBPZ. Okay. So the Z means that it's a zip file. So go ahead and click on Save. Okay. And it's going to ask you what you want to archive. Just use the default settings and click Archive. Okay. Okay. All right. And then if you go to your documents here, okay, you'll see that there are 2 files that are saved. So there's a WBPJ. So that's the default project file for ANSYS. But what ANSYS doesn't tell you is that this is just like a shortcut file. So actually all of your files, you'll see that there's another folder here. This one has all of your geometries and your finite element results in there, right? And so if you actually try to move these 2 to your home computer, you're going to see that it's actually impossible to open. So the way to actually transport your project from computer to computer is you need to transport this zip file, so this WBPZ. So this is the one you need to save to Dropbox. This is the one you need to save on your flash drive to kind of bring between different computers. Okay. So for this project, probably not that big a deal, but always good to kind of know how to move this in between computers. Chad, do you have a question?
Oh, yeah, just about the pressure.
Yeah. Okay, let me come to that.
All right. There's a applied by and loaded area categories.
Yeah, so this is an old interface. So actually, this is the interface from like 2020. It doesn't really matter. Yeah. Yeah, so that goes to units. And so that's under third option, millimeters per gram. Yeah. Yep. What's up?
Alright, so here, I don't see it.
They might have changed the name for it, so.
Space machine.
So for this one, don't worry about the different objects, just because, we're just making a basic mesh. So just go ahead and click on generate mesh.
Okay.
And the way to change the sizing is that you can change the sizing. Yes, the default is I think 30 millimeters, but I think for this one I used 10 millimeters. Yeah, so go ahead and right click on mesh, and let's just go ahead and generate. Yeah, so that's good for that. But for the change so I think one of the parts later is if you want to change the element shape, and so you can choose that here. So instead of quad dominant. Yeah, the main thing is we want to change the shape. So go ahead and right click on mesh. Yeah, let me see what options are there. Oh, methods right here. It's the first one. Yeah, so you can change the shape of the. Okay. But don't worry about that for now. But for now, just do the sizing. So go ahead and right click on this and delete.
Oh, which one?
Right click on automatic method. Okay. Just go ahead and delete it. Yeah, so you'll use that for some of the activities later on in the thing, but for now, just the sides. So go ahead and just regenerate. Okay. And then from there, you can apply the back.
I don't like the pressure. Just static structure.
Yep.
And for some reason it's not being able
So what happened here was that, so we were able to apply the pressure on a line there because we set the analysis to 2D. But if your analysis is set to 3D from the beginning, so a pressure is a force over an area, so it's expecting you to select an area. You see the mesh.
There you go.
Okay. Yeah, so what happens is that if you click on geometry here, you see the analysis factor is 3D. So this needs to be 2D in order for you to apply pressure. Yeah, so this is kind of a weird thing that occurs. So you can't actually apply pressure on this. So you can only apply pressure on this surface here. So if you want to get the results exactly like the instructions, you would have to unfortunately start over again with the 2D. But another way you can do is you can just apply a force and apply it here. Right, so you can apply a force on the line. You can change this to components. And then you just have to individually, well, there's only one component, but you have to basically convert the 1 × 10⁴ megapascal into newtons. Because you can compute this area, right? So this area, this surface here has a thickness of 5 millimeters, has a length of 200 millimeters. So you can compute exactly how much force will be applied from that pressure. Yeah, that's probably easier to do than starting.
Okay.
Yep.
Thank you. Yeah.
Oh yeah. I'm just playing around with it.
Okay.
I don't know how to better.
Yeah, the mouse controls are kind of weird. I think they're different than SolidWorks and stuff. But yeah, a lot of things are actually mapped to the middle mouse button, which is kind of interesting. But if you want to pan, you can hold Control on the keyboard and then hold the middle click. Yeah.
Oh, perfect.
Yeah. Yeah, I end up using panning a lot. So yeah.
Will there be issues? Let's say this was 20, what's on 2025, right?
Yeah.
Let's say you did it at home and you have 2026 and then you come here to do it. Will there be, and this is 25, will there be issues?
Yes.
Okay.
So you can go backwards. So you can take a 2026 file and excuse me, you can take a 2025 file and load it into 2026, but you can't go the other way. So you can't, if you open it up in 2026, you cannot load it in 2025.
Yeah. Is there any way how to save how to save
Uh,
25 into
that's a
using
great
26?
question. I don't think so because there's only one file format. It's just that they change the metadata for every year for whatever
Oh.
reason. That's how they basically encourage people to buy the new version of the software. So yeah, it's very annoying, but that's also how they make money. So
Yeah. Okay. I know there's other softwares like Abacus and is do they all kind of do this, or sorry, give the same results, or is one known as better for certain applications?
Abacus and ANSYS are very similar. I would say Abacus is used more for research applications, just because its roots were kind of as a research software it's first, and then it kind of transformed it into a commercial code from there. ANSYS kind of took the other route where it was kind of designed as a commercial product first. So there are, I would say ANSYS is more used in industry. I think generally they have a better, you know, like licensing package or a cheaper licensing package for companies to do than Abacus. But in terms of performance, I would say for the most part, they're very similar. I think there are niche cases for both where one is better than the other. But for the most part, for most cases, they're pretty similar. It's more about kind of what you learn in school and kind of what interface you're used to. Yeah, so because I know for a time, Dr. Sanders actually fought really hard to get Abacus here because that's the software that he learned when he was in school.
Oh, okay.
But there's a lot of red tape here. It was very difficult to do that. Yeah, it was very frustrating. I remember talking to him at the time. So, but I just gave up. I said, let's just use ANSYS.
What's your take on, for example, because SolidWorks has its own FEA.
Yeah.
Everyone has their own FEA. Is there
Yep.
I don't know, is it better to just use like a discrete, like FEA only, or
Yeah, no, I can't say I have enough experience with SolidWorks FEA. They're relatively new to the game. And a lot of people I talk to, haven't really used it all that much. I would say, for pretty basic stuff, like if you're just applying forces on a structure, I'd say SolidWorks FEA probably works fine for that. If it didn't, there would be big issues.
Yeah.
But the thing is with FEA, it's always in the niche cases where it's like, that's where you kind of see the differences in the softwares. So I would say for simple cases, like everything we're doing in this class is probably fine. But ANSYS has, part of the reason you pay for ANSYS is that you pay for the legacy and you pay for the reliability that, people have used ANSYS for so many years. But SolidWorks, they don't have that history yet. They will eventually, if they continue to do well. But yeah, I would say, for the most part, people trust ANSYS more than SolidWorks right now.
Okay.
About the assignment.
Yep.
It says for number 2, part A, it says change from 10,000 megapascals to 25,000.
Yep.
But the instructions use
it should be 10,000, or maybe somewhere in the middle. I forgot to change it, but it should be 10,000 from the beginning. So if you go back to the start, it should be 1 times 10 to the 4th megapascal. Yeah. I think probably somewhere in the middle there's a typo. So it should be 10,000. All right, so we're getting down to the last 30 seconds. Any last minute questions before we start wrapping up? Okay, all right, so I'm gonna start shutting down. I'll stick around for a couple minutes, and then we'll probably head out. So thank you guys for coming today. Hope you have a good weekend, and I will see you guys next week.